Let's do a demo on the sweep surface using conical types. So it's going to be a conical surface. I'll start this out by trying to explain the conical surface in the sketch environment. So just working with this like on a 2D situation, let's just create a line. Just two random lines. Alright, so now what I want to do is create a parallelogram. So I'm going to create a line that comes off of this endpoint and goes up here and is tangent. So I'm hoping to get that tangent symbol to show up. So this line is tangent to this line. I'm going to try and do the same thing on the other side. This line is tangent to this line. If you don't get them tangent, you can use your control button. Grab both the lines and then use the dialog box and select tangent. Okay, these are already tangent, so I should be good to go. And now what I'm going to create is a parallel line from this endpoint, and I'm going to move this around. I'm going to let that parallelism lock in, and then from the end of this line, whoops, I missed. The end of that line, and then move it around until it shows parallelism. What I've just created is a parallelogram. So let's take these two lines and make this thicker. I'll do salmon color and why is that? That does not look thicker to me. I'm using the control button, and then we're going to right click and go to properties. Just seems like it should have got thicker. Right, you got those two salmon colored lines, and the black lines represent a parallelogram I created. I'm going to create an axis that goes right down the center. Oh, I missed. Let's try that again. We're going to create an axis. Make sure you wait for the intersection thing to highlight. And then I'll get over here on that one. Okay, so I've divided that right in half. I'm going to click a line from here to here. That divides that parallelogram in half. Okay, so if my goal were to create a line or connect this line to this line, sure, I could go to the line command and connect that. That would be a line connecting the lines, but what I have is discontinuity and tangency, meaning that this is not a smooth transition. There's an angle from the salmon colored line to the blue line, and from the blue line to the salmon colored line there would be an angle between the lines. That would not be a smooth transition. A smooth transition would be an angle of 0 degrees or 180, representing a tangent transition. So if I want to get a smooth tangent transition, you might think to go to corner and corner these two. But what's happening is I just stretched the pink lines. I do have tangency, it's nice and smooth, but if my limits have to stay here, then what we need to do is build a parallelogram. Parallelogram is made up of an ellipse, parabola, or hyperbola. So if you were connecting these lines, anything that would come below this center line here, if there were a curve coming down below, it would not be tangent. Okay, it would be concaved. So we have to have it above here. So it'd have to be any kind of curve that could go from here and then wrap back around to this end. Any curve that would go above this and back down would create a discontinuity and tangency. So you'd have to be, the curve would have to come in below these two lines representing the parallelogram. I'm going to create points, equal distances along this line. I'm going to do 3 points. By creating 3 points, I can see I'm creating equal distance between each point. So each point represents 25%. So you have 25%, 50%, 75%, and then 100%. Any curve connecting the two salmon colored lines that passes through this point at 75% is known as a parallelogram. Any curve below that point would be an ellipse, and any curve above that point would be a hyperbola. So I'm going to go to the conic feature. Oops. I forgot what conic is for a sec here. Okay, so I'm going to go to the conic feature, and you must use this one here. It's called the tangent intersection point. So I'm going to click on that. I'm going to start at this point, and it's asking me for an end point in the tool palette. So I'm going to end here, and it now asks for the tangent intersection. This line that is tangent to the salmon colored line, and this line that is tangent to the salmon colored line, where they intersect is the tangent intersection. So the tangent intersection is here, and then this point right here at 0.75 is a parameter of 0.5. As you can see in the tool tablet up above here in the parameters, when I put my cursor on that point, I got to get it right on that point. With it being on that point, if I click, it creates a conic. I'll change that color. So here we have a green curve that is a conical curve. It's a parabola. It's tangent to the salmon colored line, tangent to the salmon colored line. Okay, and then you have this green curve. Again, that's your parabola. That creates that smooth transition from one line to the next. This is the smoothest, most aerodynamic type of curve I can create between these two lines. If you want to get this to come up maybe not quite that high, you could go back to conic. Start point, again, I'll use the left point, and then the right point, and then the top intersection, because that's an intersection point. And then I could click down here. You can also key in a parameter. Any parameter value of 0.5, less than 0.5 and greater than 0 will create an ellipse. So for example, 0.25 creates me an ellipse. That's a conic, and I'll go to properties and we'll just change that color. Let's try this one. All right. Might not have been the best choice. Let's try a different color. Looks too close to the black. All right, so any curve that goes below the green line, green curve, is an ellipse. And now we'll try and create a hyperbola. Again, I'm going to go to conic. The tool palette asks for a point, and then it asks for a second point, the end point, and then it asks for the tangent intersection point, and then any point above this, I'll just click anywhere above there. And then this conic is called a hyperbola. For your own reference, you might want to create this, define each one, so you have reference to what conics are. Conics are a type of curve that fits inside this parallelogram. Also, another way to think of a conic is any way you can slice a cone will give you a conical shape or a conical curve. All right, I'm gonna let you guys ponder on that and make a new demo or a second demo to this conical surface. So this was just to get a kind of concept. What are you creating when you're creating a conical curve? This is in the 2D environment. The next one will be in the 3D environment.